This week we'll be talking about principles of spreadsheet engineering. If you look at any company today, you will see that they use spreadsheets for many different types of decision making. Mundane day-to-day decisions or very critical, important decisions. Sometimes a spreadsheet could be used as a database just to store the customer information. Sometimes a spreadsheet can be used to budget the next 10 years of a certain project. It's great that companies use spreadsheets for decision making. What's not so great is that they do not spend a lot of time to engineer well-created spreadsheets. There has been a lot of research on spreadsheet errors, and it's been shown time and again that most spreadsheets contain errors. And these errors multiply with use, especially if they are used by many different people. So, if a company is using spreadsheets for critical decisions, how can we reduce, if not eliminate, these errors? The answer comes from spreadsheet engineering. Can you imagine a construction company building a new house without a blueprint, without a plan? Without plans, structure will fail. And without plans, spreadsheets will fail to be effective. In any production process, in any building process, if you do some advanced planning in your design, you will always have a speedier implementation. You will also have an implementation that's more accurate. Since spreadsheets are very important for businesses, they should be treated no different than any other area of design. And we should take principles from other advanced planning techniques, and especially engineering. In fact, especially software engineering, to make sure that spreadsheets are more effective. Our goal today is to outline a process that's going to make spreadsheet creation more efficient, more effective. And at the end of the day, a well-engineered spreadsheet will help everyone, including the person who created the spreadsheet. Imagine yourself. How often did you find yourself opening up a spreadsheet that you created a month ago, a year ago, and then you have no idea what you have done? The main reason you have no idea what you have done is because you have not created a well-crafted, well-engineered spreadsheet. So today we're going to look at 3 phases of spreadsheet engineering. How to design a good spreadsheet, how to build a good spreadsheet, and then how to test whether your spreadsheet works well or not. In the designing phase, we will look at the following steps. Now let's go over them one by one. Like any carpenter will tell you, before cutting, you should measure twice, because once you cut, there is no going back. That's the same thing with spreadsheets too. Before you create your spreadsheet, if you plan well, then you're going to make less mistakes. Before you start typing away, you should try to step away from your computer and try to sit down and think, what am I trying to accomplish with this workbook? In fact, ideally you should begin with a sketch. Get a pen, get a paper, try to write down what are the inputs, what are the outputs, what do you want the spreadsheet to do, who will use it, for which purposes. If you can anticipate how the model is going to be used ultimately, you can create a robust and flexible spreadsheet. Make sure that your design is modularized. Similar items should be grouped together, unlike items should be separated. If you have an influence diagram that you created for your model, it'll help you identify what comes into the model, what goes out of the model. Again, this will help you modularize. And since most of your readers are going to be English-speaking readers, your spreadsheet should flow from left to right, top to bottom. So your formula should also generally refer to cells that are above and to the left of where they are. Your sketch should be a full design, but when you're trying to create a spreadsheet, make sure that you build it one module at a time. That way you'll be able to find small local mistakes before you create the whole thing, and it'll be much harder to detect big mistakes. Your workbook should be designed that all your parameters should be in a single location away from your calculations. Also, no formulas should contain any constants, any numerical values. Any numbers you use in a formula should reside in cell references. Parameterization helps you identify the parameters easily. It will help you with sensitivity analysis, which we'll talk about in a couple of weeks. And it's also a good way of documenting what the spreadsheet does. It will make your spreadsheet more readable. If you can, keep it simple. If you have a complex spreadsheet, it'll be harder to build, harder to understand, harder to debug. And nobody wants that. When you're trying to write your formulas, if you can decompose complex formulas into smaller intermediate steps, that's much better. Spreadsheets usually live longer than expected. That's why you always need to make sure that you have enough design for communication. You should have labels, good use of blank spaces, colors, fonts to leave visual cues to the readers, whether it's you or some other user. Split windows can be important when you're viewing the spreadsheet. Make sure that you document all of the important stuff. Record your source for important parameters. This will come in handy if there is something wrong with the output of the model and the incorrectness stems from the input parameters. Then you can say, oh, I got this number from here. Let's trace the source and figure out what's going on. If you have important and complicated formulas, they should be explained. And whenever needed, you should use cell comments to describe what's going on in a particular cell. Use cell comments conservatively though. You don't want a spreadsheet that's full of cell comments. If you think you have to explain a lot of different cells, you should consider creating a separate module to list all your assumptions. When you're designing your workbooks, keep these three things in mind. Separate sheets for separate pieces of information. Think about navigation and protect your workbooks if you need to. You should make sure that sheets that have similar information should be separated from one another. For example, it'll help you isolate technical details of a model on one sheet that users don't need to see. Or the assumptions should be in one worksheet that everybody can take a look at. And results can be in one sheet. Perhaps some people would only want to look at results. Ideally, even if you have a worksheet that has multiple sheets, users should only interact with one or two easily recognizable sheets. When you're creating your worksheets, any form of structure that'll help user navigate the workbook better is important. So try to think about how the information flows in your workbooks. And make sure that your individual sheets are properly named so that you actually leave more visual cues and explanations to the user just by using sheet names. If you need your workbook not to be tampered with a lot, make sure that you use protection. Lock the cells that you don't want to be changed, use worksheet protection if necessary, and use data validation. Once the design step is over, the next step is building the spreadsheet. Make sure that you follow the plan you have created. You should build one module at a time. As you're typing your formulas, try to predict the outcome of each formula. When you're copying and pasting, do it carefully. In general, retyping increases your chance of errors, so it's best to copy-paste whenever you can. Absolute and relative referencing, which we briefly talked about again when we were talking about the lookup functions, are very important for efficient copying. You need to make sure that you know the difference between relative and absolute referencing well and use them smartly to make your spreadsheet easier to create. Use the function wizard for any function that you're not fully familiar with. In Excel, you can name any particular cell or range of cells. And these references can be used in formulas which make your formulas more readable, sometimes easier to debug and easier to use. In some situations, they may require extra work to enter and maintain, but overall, they might be helpful to you. We will talk about how to create these range names as we're going through this week's examples, and I will also give you some in-class examples as well. You designed your workbook, you built your workbook. The next and the last step is test your workbook, test your spreadsheet. In testing, there are three major things you need to do. Are the numerical results looking plausible? Are they believable? Are they making sense? Are your formulas correct? Is the overall performance of the model what you're expecting? To check the numerical results, you need to think about rough estimates. Is this the number I expect to see at the end of this calculation? If you're dealing with a very critical spreadsheet, there is no shame in bringing out your calculator and double checking your answer with a calculator. And try to test some extreme cases. For extreme cases, for example, I try to enter 0 for most of the input variables or really large numbers. The goal is stress testing your spreadsheet and trying out some unlikely cases, see how your spreadsheet is going to hold up. When you're checking your formulas, you can check them manually. You can display individual cell references by just clicking on them. You can display all formulas, use the auditing tools, or use error checking. Checking the formulas manually is pretty straightforward, but doing this one by one can be tedious. You can also click on cell references to see how the formulas look. What I like about Excel's latest versions is that when you click on a formula, different cells gets highlighted in different colors, and those color codes help you trace what the formula is doing a bit more easily. In Microsoft Excel, if you hold down the Control key and push the tilde button, then you will actually see all your formulas displayed in your current worksheet. This makes it very easy to scan your formulas and see if there is any unusual patterns. And then you can reverse this effect by pushing Control tilde again and toggle back and forth between the formula view and the number view. Another important tool is Excel's auditing tool, which I will show you when we are done with today's first exercise. And lastly, Excel has a way of checking whether the formulas look correct or not. So to summarize, it's important to create a well-engineered spreadsheet so that you minimize the chance of making mistakes when you use spreadsheets for critical decision making in your business. And if you'd like to engineer a good spreadsheet, you need to design well, build well, and test well.